Hey guys, welcome to CPM 2. This is Module 4, Lesson 3. This is actually a really short lesson. This lesson is actually only 3 pages. And this first page is a straight review from your first lesson in this module. So the reason I did this review is you're going to have some questions like this on my math lab. So your review, example A, says write each fraction as a decimal. This is calculator work. This is when you just divide the numerator by the denominator. So in your calculator, you're just doing 3 divided by 5. So when you put that in your calculator, you get 0.6. Now, these next 2 are a little bit harder to show you. Actually, the next 4. Same thing here. You're putting this in your calculator. 1 divided by 3. When you do 1 divided by 3 in your calculator, you'll see this 3 and it just keeps repeating and repeating forever. So that's when you shorthand that with the 0.3 and that line over it. Okay, on C, you're doing the same thing. We know that this is going to be negative because it's a negative in front. So in your calculator, negative 3 divided by 11. This one's a little bit different because it's going to give you like a 0.272727, and that 272727 is just going to keep repeating and repeating. So on this one, when you write this, you have your 27, and because both of these are repeating just back and forth, 27272727, you need a line over both of those. Okay, because not just one or the other is repeating, both of them is repeating. So then on D here, when you put this one in your calculator, 5 divided by 6, on this one you get 0.8, and then the 3 is just continuously repeating. So when that happens, now you're going to have 0.83 with the bar only over the 3. If you put it over both of them like we did here, that means it's the 8's repeating too, so it'd be 0.8383838383, but it's not, just that 3 is repeating, so only the bar goes over that 3. So, bar only over what you have repeating there. Okay, so that's a review from Lesson 1. Along with your review from Lesson 1, we need to compare our decimals and fractions. So when you do this, just turn your fractions into decimals. So in your calculator, 1 divided by 8 gives you 0.12. And here we have 0.12. So you need these to have the same amount of decimals. This has 1, 2, 3 decimals. This one only has 1, 2. So I'm going to make that third one become a 0. So now just compare each digit to each digit until you find one that's different. You have the 1 and the 1. Those are the same. 2 and 2. Those are the same. But now I have a 5 and a 0. So which one of those is bigger? That 5. So your Pac-Man eats that bigger number. Okay, same thing here. Divide. 1 divided by 5 gives you 0.2. Here I have 0.25. So I need both of these to have 2 decimals. So we'll put a 0. So compare. You got 2 and 2. Those are both the same. We have a 0 and a 5. That 5 is still bigger. So your Pac-Man eats that bigger number. Now this one's a tricky one. When you put this in your calculator, you get 0.7. A lot of times when you have something like this, we want to say that these are equal, but they are not equal. That bar means that this keeps repeating forever. So this is 0.77. So make this one have 2 digits as well. And really, you know, those 7s keep going and going and going, but I'm only going to write one more. So now I can compare. We've got a 7 and a 7, but now I have a 0 and a 7. That 7 is bigger. So this one right here is the bigger number. So be careful on ones like that. And then our last one is evaluate. Again, this is a review from your first lesson. Evaluate just means plug this in. And when we plug this in, we need to plug this in with parentheses. But we're going to keep going until we get to a single number answer. Okay, so tell me x is 2.7, so plug that in. Get in the habit of plugging these in with parentheses. So that means I've got -3 times 2.7 plus 4. Hallelujah for calculators. So put this all in your calculator, just the way you see it here. And your calculator is going to spit out a -4.1. Okay, calculator work after you plug that in. Here we got y squared. For y is, weirdly enough, -4.1. Plug that in with parentheses. So you've got -4.1 in parentheses squared. You have to put this in your calculator with the parentheses too. So when you put that in, you should get a positive 16.81. Reason is, that is -4.1 times -4.1. So those two negatives end up turning that positive. If you don't put that in with parentheses, okay, I'm putting this in a lighter color so we know it's not right. I said without parentheses. All that is getting squared is that 4.1. So we have 4.1 times 4.1, and then that negative comes down. So you're going to end up getting a -16.81, which is not the correct answer. Okay, so that's why those parentheses really make a difference. You've got to make sure you put it in with parentheses. Okay, so far this has just been a review. So let's turn this page and let's get into the actual lesson, which is solving equations that contain decimals. Okay, so here's our steps for solving for x. It says if the fraction is present, multiply both sides of the equation by the LCD. Okay, and this really and truly is an optional rule. If parentheses are present, use the distributive property. We need to combine any like terms. Step 4 is to use the addition property of equality. So you're going to rewrite the equation so that the variable is on one side of the equation and the constant is on the other side. So you want the equal sign to divide to separate the two. And then step 5 is to divide. Okay, now we've been solving equations before without decimals. These are the exact same thing. Now I will show you on this last page here, example 2, how to solve it where you get rid of your decimal. But really and truly, because we have calculators and we can use calculators now, there's no reason for that extra step to get rid of decimals. Okay, so until the very end, I'm going to be dealing with these as decimals. They're just numbers, so treat them as a whole number. On A, you have x minus 1.5 equals 8. So the opposite, what's happening to x, we are subtracting 1.5 from it. So the opposite operation is to add that over. And what I do to one side of the equation, I must also do to the other side. So I've got x equals This one's really not hard to do by hand. 8 plus 1 is 9, and then carry down your 0.5, but put these in your calculator. Okay. So my answer is x equals 9.5. Same thing on B. What's happening between this decimal, this 0.17, and x? If you don't see an operation, if you don't see an addition sign, a subtraction sign, a division sign, if they're right next to each other, that means they're being multiplied. So the opposite of multiplying x by 0.17 is to divide 1.7. And what I do to one side of this equation, we're doing to the other side as well. So my decimal cancels. I'm left with x. And then in your calculator, negative 0.34 divided by 0.17 is going to give me a nice and pretty negative 2. Okay, so these were both one-step equations. So now let's go to two-step equations. On C, we've got 1.2x plus 5.8, and that equals 8.2. So we're on this step right here. I need to get my constant term on one side, my number, and my variable term on the other side. So I have my variable term over here, right? Variable over here. So we need to get our number, our constant, over here. So the opposite of adding 5.8 is to subtract 5.8. So I get 1.2x equals, put that in your calculator, 8.2 plus, minus 5.8 is 2.4. Then my last step is to divide. That's 1.2 times x. The opposite is to divide. So we'll divide that over. And we'll get x equals, put this in your calculator, we're going to get a nice even 2. Okay, same thing on this one. Right, okay, and by the way, I said variable over here, number over here. Notice that's what we did. I didn't really kind of go back into that. There's my variable term. There's my number term. Okay. Now, this one's going to be opposite because now my variable's over here. So, because it's already by itself on this side, let's go variable here, my constant, my number over here. So, we need to move this over here. So, the opposite of a positive 1.7 is a negative 1.7. So, we will get 1.2 equals 0.3x. And then my last, so we've done that now, right? Variables on one side, my constants on the other side. So now divide. We're going to divide by 0.3 on both sides. And we'll get 4 equals x, or x equals 4. Okay, either of those are fine. You can kind of tell which version I like, though, you know what I mean? But it doesn't matter how you write that. So we had one-step equations and two-step equations. When we turn to the next page, we're going to have 4 more that are multi-step. But as you can see here, you're treating these just like numbers. Okay, so don't let the decimal trip you up. You've got a calculator. Your calculator's not afraid of decimals, so don't be either. On E, notice here we don't have anything on one side. I've got a variable on both sides, and I've got a number on both sides. So just get something to one side, the other one to the other side. I'm going to go variable over here, constant over here. So how do I move this 4x over here? Well, the opposite of a positive 4x would be a negative 4x. So 7x minus 4x gives me 3x. Bring everything else down. So plus 3.2 equals, don't lose that negative there, equals a negative 1.6. So now I have my variable over here, right? It's right here, you got no variable over here. So now let's get the constant over here. So I need to move this to this side. Well, the opposite of a negative, or sorry, opposite of adding 3.2 is to subtract it. So I'm going to get 3x equals, put this in your calculator, we're going to get negative 4.8, and then my last step is to divide. Now on that front page, every time we solved a problem, we got a whole number. I'll be honest with you, that happens very rarely when you've got decimals in your equations. So when you put this in your calculator, you get negative 1.6, and that's okay. You're going to get a lot of decimal answers today. Like I said, it's kind of rare for you not to get a decimal answer when you have decimal equations. Okay, F. Now I need to distribute. So I've got 5 times x and 5 times a negative 0.36. So it's going to give me a negative 1.8. I'm going to bring the rest of this down, so equals negative x plus 2.4. And now my equation looks exactly how it was over here. So now, let's get your variable on one side, your constant on the other. So if I picked out my variable over here, I need to take this x and move it over here. So the opposite of a negative x is a positive one, so we're going to add it on over. So I've got 6x minus 1.8 equals 2.4. You need to bring everything else down we haven't used. So now I've got my variable over here. Let's get our constant over here. So I need to move this over. So the opposite of a negative 1.8 or subtracting a 1.8 is to add it on over. So I've got 6x equals, put this in your calculator, we get 4.2. And then my last step is to divide. So we're going to divide both sides by 6. And we'll get x equals 0.7. All right, G is a lot the same way. It's just now I'm distributing on this side over here. So I'm going to bring down this side. We've got 6.3 minus 5x equals, we need to do 3 times x and 3 times 2.9. Okay, so now I'm exactly where I started here and where I was here after I distributed. Get your variable to one side, your constant to the other. I'm always a fan, I'm not going to say always, okay, because that's not true, but I'm usually a fan of variable over here and number over here. So let's do this again. So if I want to get my variable to the left, the opposite of a positive 3x is to subtract it. Okay, this is another reason your calculator is going to come in handy. If you're not good with your integer rules, use your calculator. I'm going to get 6.3 when you put in your calculator, negative 5 minus 3, we get a negative 8x. Bring down your equals and your 8.7. So now I've got my variable over here. Let's get my constant over here. So I need to move this over here. So the opposite of a positive 6.3 is a negative 1, so we're going to subtract it over. So I get negative 8x equals Put this in your calculator, and we get 2.4. And then divide by -8. So we will get x equals -0.3. All right, and then on H, same thing, we got parentheses, so I need to distribute first. 7 times x is 7x. 7 times 8.6 is 60.2. Bring down your equals 6x. Now this one's a different one, I told you, right? I usually like variable on the left, constant on the right. But here, notice you already have your constant by itself. So on this one, we're going to go constant here, variable here. So because my constant is here, we're done with that one. So let's get this one to this side over here. So opposite of a positive 7x is to subtract it over. Now be careful here. We can bring down our 60.2. 6 minus 7, again, if you're not good with your integer rules, put this in your calculator. But you're going to get a -1, so either -1x or just a -x. Now, I don't want to solve for a -x. I want to still solve for a +1. So we need to divide both sides by -1. My negatives cancel, and we're left with -60.2 equals now a +x. And again, you can switch that, but I don't have room to switch it. Okay, so here's our last example. And notice example 2, these are both the same. I'm going to show you 2 different ways to solve this. It says right here, instead of solving equations with decimals, sometimes it may be easier to first rewrite the equation so that it contains integers only. So what I mean by integers is whole numbers, no decimals. Recall that multiplying a decimal by a power of 10, such as 10, 100, or 1,000, has the effect of moving the decimal to the right. So, example 2, solve part A with the decimals. So, solve this one just like you normally would. So here, how would we solve this for y? Well, we know that the opposite of adding 2.3 is to subtract it. And we're going to do that to both sides. So I get 0.5y equals a negative, I don't know, a negative something. A negative 0.65. Then we'll divide by 0.5, divide by 0.5, and we've got y equals negative 1.3. Okay, so this is how we've solved every problem in this lesson so far. Here is the other way to do it. And again, I'm not a fan because I feel like this is an extra step. And you've got calculators, so these decimals aren't a problem when you've got calculators. But over here on B, it says we're going to solve part B by getting rid of the decimal first. And so when you get rid of the decimal, that's when you're multiplying it by one of these power of 10s. Now, to pick out which power of 10 you want to do, you want to see how many times you want to move the decimal. If you want to move the decimal only one time, you're using 10. If you want to move it 2 times, you're using 100. If you need to move that decimal 3 times, you're using 1,000. You're using however many times you need to move the decimal, that's how many zeros you need. So when you look at our problem, to make this into a whole number, I only need to move this decimal once. To make this one into a whole number, I only need to move this decimal once. But to make this one into a whole number, I need to move this one 2 times. So because I need to move one of them 2 times, we're going to multiply everything by 100. So I'm going to multiply this by 100, this by 100, and this by 100. Okay, and a lot of times you'll see people just kind of do something like this where they put the whole thing in parentheses and then 100. So either use your calculator or just move your decimal. When you do 100 times 0.5, you've got 0.5. We're going to move this 2 places, put in that 0. This becomes 50y. 100 times 2.3 means I have 2.3. I'm moving this 2 times, put in your 0. This becomes plus 230. And then 100 times 1.65 means we're moving this 2 times, so this becomes 165. Okay, so notice now I've gotten rid of all of my decimals. And just kind of be careful, even though you only need to multiply this one by 10, if you need to multiply one of them by a bigger number, you've got to multiply them all by a bigger number. Okay. So now we have whole numbers, so now let's solve. So to get this y by itself, we're going to subtract 230 over. So I get 50y equals 165 minus 230 gives me negative 65. Divide by 50. And it's a miracle, I still get a negative 1.3. Okay, so if you like this part B method better, I'm sorry, I'm only showing you one example of it. Again, I think this is unnecessary. Where that is an option to multiply everything by one of these powers of 10 to get rid of all of your decimals, and then you're good to go. All right, guys, as usual, let me know if you have any questions, and you can, of course, pause and rewind this video as much as you need.